Hi, my name is Jonah M. I'm a rising junior at UNC Chapel Hill. I'm a biology major and a chemistry minor, and I would like to work as a medical oncologist in the future. I've taken Chem 101, 102, 261, and 262, and have received an A in all courses. And I would like to be a chemistry peer mentor because I personally struggled a lot in a lot of the chemistry courses I've taken at UNC, especially Chem 261 and 262. And the willingness of peer mentors to help me work through problems that I was struggling with meant a lot to me, and it really encouraged me to do better in these courses and try harder. And I would like to provide that same encouragement and that same help to other students at UNC because I know that all of them are very capable, and with the right guidance, they can succeed in challenging courses.
So the problem that I chose for us to review today is from the aromaticity unit in Organic Chemistry 2. In the reactant, we have a benzene ring. In the product, we also have a benzene ring, but it's bound to a bromine, isopropyl group, and a carbonyl carbon that has a chain. So I first like to start these problems by acknowledging which of the substituents, if bound first, will lead to the binding of the other two substituents. And what I mean by that is if we first start with the binding of the bromine, bromine promotes ortho-para binding. We can definitely lead to the binding of the isopropyl group because it's in the ortho position, but we can't lead to the binding of the carbonyl carbon because it's in the meta position. But if we start with the isopropyl group, for example, since it's electron donating, it'll also add ortho-para. Bromine is in the ortho position, the carbonyl group is in the para position, so the binding of the isopropyl group first is a good idea. So the way we can do this is by a Friedel-Crafts reaction. And that'll lead to this product right here. So what we have to consider next is which dye-substituted product will lead to the binding of the third substituent. So for example, if we add bromine next, bromine likes to add ortho-para. So it'll want to add ortho right here or para over here. The the isopropyl group will want to add ortho-para as well. So it'll either want to add here or here. And as you can see, there's no consensus for which carbon the third substituent should add to. But if we take the next steps by adding, let's say, the carbonyl group second, this will want to add ortho-para, so it'll either want to add here, here, and the para position is already occupied, so it's the two ortho positions. And since this is an electron withdrawing group, it'll want to add meta. Meta is the same consensus for these two carbons. And as you can see in our product, we want the bromine to be directly adjacent to the isopropyl group. And if we add the bromine here or here, it'll be the same product. So that means if we do another Friedel-Crafts reaction, and produce this product right here, it'll line us up nicely for adding the third substituent. So since there is consensus between these two groups to add to either this carbon or this carbon, all we have to do left is add the bromine group. And we can do so by adding Br2 and a Lewis acid, FeBr3, and that'll make this product. Bromine either added here, or the bromine could have added here. Regardless, it is the same product.